In the last lesson, we learned some techniques for analyzing the distribution of a single categorical variable. We could use frequency or relative frequency tables. We could graph the data using pie charts or bar graphs. So what do we do if the data involves two categorical variables? In this example, 200 children in the United Kingdom were selected and asked and recorded by gender and asked what superpower they would most like to have: invisibility, super strength, telepathy, ability to fly, or ability to freeze time. And these are the results. All right? This is what is called a two-way table. Two ways because we have both females and males. Now, in this graph, superpowers, or in this table of superpowers, is the row variable, and gender is the column variable. But we could just have easily have switched these. So you are allowed to switch rows with the columns. In other words, we could have had the male and female for our rows and the superpowers going across for our columns. The distribution of superpower alone or gender alone are called the marginal distribution. So we're talking about these right here in the margins. Okay, so what is a marginal distribution? Well, it's one of the categorical variables of a two-way table of counts is the distribution of the variable among all individuals. So we're talking about each one of these among all of the individuals. So to find the marginal distributions in percents of superpower preferences, to calculate that, we find the percent among all of them. Okay, so we use the data from the two-way table to calculate our marginal distributions in percents. So invisibility would be 30 over 200, which is 15%. Super strength, 20 over 200, which is 10%. And telepathy, 44 over 200, which is 22%. Flying would be 54 over 200, which is 27%. And freeze time is 52 over 200, which is 26%. Okay, so you could make a graph to see this. I hope this is big enough that you can see it. But you can see all of the marginal distribution here. Now would be a good time to stop and check your understanding on page 14. Okay, so there were 2,367 females, 2,459 males, and 4,826 total in the data set. This means that 49% are female and 51% are male. And your table should look similar to this being the female and this being the male. The two-way table contains much more information than the two marginal distributions of opinion alone or gender alone. They tell us absolutely nothing about the relationship between the two variables. We can look at the females alone and find the percent of women. If we calculate all these percents of all the women, we're talking about conditional distribution. So the conditional distribution, the values of a variable among individuals who have a specific value of another variable. Okay, so what is a conditional distribution? It's the values of a variable among individuals who have a specific value of another variable. So how many conditional distributions are there in a two-way table? Well, there's two sets of them, but it's 2 times the number of cells. So if we were looking at just gender, there would be 2. male and female. But if we were looking at the superpowers, then there were 5 of those. Okay, so how many conditional distributions are there on a two-way table? There's 2 sets, or 2 times the number of cells. Okay, example. Calculate the conditional distribution for the data in the two-way table about superpower preferences for males and females. It's a good idea to cover up a column at a time. If we were to calculate these, we would find that 15% of the females and 15% of the males wanted invisibility, where super strength, only 3% of the females and 20% of the males would like to have super strength. Telepathy, 34% of the females and 6% of the males, which is pretty cool because we want to read people's minds, picked telepathy. And then flying, 31% of the females and 21% of the males wanted to fly, and to freeze time, 17% of the females wanted to freeze time and 38% of the males. What are you guys going to do while we are freezing the time? So, since there were 5 different superpowers, and there were that would be 2 times the number of superpowers, so there would be a total of 10 conditional distribution responses for males and females. Now would be a good time to check your understanding on page 17. The answer to number 1 is a 50-50 chance. Females were 49.15 and males were 51.85, so that's approximately a 50-50 chance. For the answers number 2, you're going to have to see either Miss Hines or myself to get the answer to that, because it's too much typing on this program. So when we're talking about this conditional distribution, we want to say that a conditional distribution of the superpowers among women, or the conditional distribution of superpowers among men. So we can think of it as of and among. So whatever we're looking for, it's a conditional distribution of whatever among whatever. Another thing that you should think about is which variable would be explanatory and which would be the response variable. We had that in Chapter 4, so keep that in mind, which one is which. Okay, so think about this. Although there is no surefire way to organize all data that will work for every single problem, we do have a process that could be helpful. Okay? The first step on organizing your statistical problem is to state. That means state what the question you're trying to answer. What is that question? Second step, plan. How will you go about answering the question? What statistical techniques does this problem call for? 3, do make your graphs and do carry out needed calculations. And 4, conclude. That means give your practical conclusion in the setting of the real world problem. Okay, so state, plan, do, conclude. So what does it mean for 2 variables to have an association? You can probably guess what that is. It means that there's an association between, say, the gender and what superpower they like best. For instance, in the invisibility superpower, both the males and the females, 15% of them wanted this superpower. That would be an association. So, What does the association between two variables, what does it mean for two variables to have an association? There is an association between two variables if specific values tend to occur in common with specific values of the other variable. Okay, so examples. Based on the survey data about superpower preferences, can we conclude that boys and girls differ in their preference of superpower? Given appropriate evidence to support your answer. Follow the four-step process. Okay, so what is our four-step plan? Okay, state what the question is. What is the relationship between gender and the answer to the question, what superpower would you prefer? Compare conditional distributions or your percents. Make a table. And then, of course, conclude. What is your conclusion? All right, that's it for now. Do your homework and check back with us